Hi guys, this is Mr. Teen Tutor here, and today we're going to be talking about rational functions. I have decided to split this up into two parts because for this rational function right here we have to find several things. So this is part one, we're going to be finding four things, and part two we'll be finding three things. Let us analyze this rational function right here. We need to find the domain, x-intercepts and y-intercepts, if any, test for symmetry and vertical asymptotes in this video. So before you find the domain or any of these things right here, what you want to do is to try to simplify it if you can. So let me rewrite this function. This is r of x, by the way. For whatever reason, the black pen's not working. So r of x is equal to 6x squared minus 7x minus 3 over 2x squared minus 7x plus 6. And what I mean by simplify is, can we factor this? So for those of you who don't know how to factor this kind of expression yet, let me go over that quickly. I'm assuming that you know how to factor, otherwise I don't know why you'd be watching this video if you didn't know, but anyways, I will still go over it. So this is a quadratic equation. So what you do is you find the product of a and c. So in this case it's negative 18. And then you say to yourself, what two factors of negative 18 when added together equal negative 7? Negative 9 and 2. Let's go here. 6 times 2 is 12. What are the factors of 12? What are two factors of 12 when added together equal negative 7? Negative 4 and negative 3. Now that we do that, let's replace this with negative 9x plus 2x. And same thing here. We're going to replace this middle term with negative 4x minus 3x. Or negative 4x plus negative 3x. I'm going to do it that way. Now the next thing you need to do is factor by grouping. So I'm going to group these two terms together and we group these two terms together. So let's come down here. What can I factor out of this? I can factor out a 3x, and this is times the quantity 2x minus 3. Now that you have this, when I factor this, it's plus 1 times 2x minus 3. The goal of factoring is you want to make sure that this term is the same as this. And if you get that, which I did, then you did correctly. Let's do the same here. I can factor out a 2x, x minus 2. Let's come here. How do I get x minus 2 to come out of this? So I have to factor out a negative 3. And then when I do that, you put the 2x minus 3 together, and then you combine 3x plus 1 and 1. So it's 3x plus 1 times 2x minus 3 over 2x minus 3 times x minus 2. So I have this. However, I can cancel this out. When I do that, I'm left with 3x plus 1 over x minus 2. Now, there's one thing to note though. Right here, whenever I cross out terms in the numerator and denominator, this is called a removable discontinuity, which means that when I graph this, there is going to be a hole in the graph. That's what removable discontinuity is. So basically by canceling these terms out, there is going to be a hole on the graph where the x value is 3 halves. 2x minus 3 is equal to 0. So x equals 3 halves. And we'll graph it in part 2, but you'll see soon that there's actually a hole there when x equals 3 halves. So we'll get back to that. But other than that, this is our simplified version. Now that we have that, let's go back up here. Now we need to find the domain. So domain. What are all the x values that work? Well, x minus 2 cannot equal 0, so x cannot equal 2. However, that is not the only number it can't equal. it can't equal 2x minus 3. I know you may think that canceling it out means it's just ignore it, but you can't ignore it. As you can see over the remove discontinuity, we can't ignore it there. For the domain, we can't ignore this either. So x cannot equal 2 or 3/2. So all real numbers except for 3/2 and 2. And I know some of you put in interval notation, so I'll put this like that. So negative infinity, 2 and 3/2 is closer to negative infinity than 2, so 3/2 union 3/2 comma 2 union 2 to infinity. This is one way to write it, and this is another way to write it. Both ways work. Now, find the x and y intercepts. What you need to understand is, in order to find the x-intercept, you set the numerator equal to 0, regardless. And it makes sense, because if we go back to the original and put in 0 here, this all goes out, and I'm left with this equaling 0. But let's go to our simplified version. It'll make life a lot easier. So this is equal to 0. So x is equal to negative 1/3. So our x-intercept for this function is negative 1/3 comma 0. Now, we need to find our y-intercept. Well, in order to find the y-intercept, x has to equal 0. So again, let's go to our simplified version. 3 times the quantity 0 plus 1 over 0 minus 2. So I'm 1 over negative 2, which is negative 1/2. So our y-intercept is 0, comma, negative 1/2. And it's important to keep these points in mind because then they will help you graph the function, which again we will do in part 2. Now I'm going to flip this over, and now we are going to test for symmetry. Now for symmetry, the function could either be even, odd, or neither. So it's even if f of x equals f of negative x. It's odd if f of negative x equals negative f of x, and neither means no symmetry. Now understand, terminology-wise, that if it's an even function, it's symmetrical to the y-axis. And for odd, it is symmetrical to the origin, not the x-axis, the origin. And this obviously has no symmetry. So let's see now. So does 3x plus 1 over x minus 2, that's f of x, equal negative 3x. Remember, I subbed in negative x for here, so that means negative 3x plus 1 over negative x minus 2. You can plug and chug, but you should realize that it doesn't work. Let's go to odd. This is negative 3x plus 1 over negative x minus 2. That's f of negative x. Now, negative f of x simply means multiplying this by negative 1. So when I do that, I'm basically multiplying this by negative 1. So I have negative 3x minus 1 over x minus 2. Again, you can plug and chug, but you'll soon realize that there's no symmetry there either. So as a result of that, this function has no symmetry. Alright, and then the last part for this video is we're going to find the vertical asymptotes. So in order to find the vertical asymptotes, you need to find the zeros of the denominator, which will give rise to a vertical asymptote. So x cannot equal 2. So there is a vertical asymptote at x equals 2. That is a 0 of the denominator. But now you're probably thinking that 2x minus 3 is a 0 of the denominator. But if you remember, there's actually a hole there. In fact, 3/2 is not a 0. It's in the first quadrant, we don't know which quadrant it is in. We'll figure that out. We'll have to plug and chug in a little bit in part 2. But as of now, 2 is the only 0. 2x minus 3 is not a 0. If you cancel two terms out, you've just eliminated 0. So we have only this vertical asymptote. Now please click on part 2 of this video and we'll finish up this problem.